Hello students, welcome once again to Purnang. So that was the question from our complex number chapter which we are continuing with. Okay, so see the purpose of this question again. The purpose is the algebraic part. We have seen the question based on like roots of unity, the geometrical aspect, and we will be continuously seeing few more questions based on all such concepts. But here one simple thing you should always keep in your mind, whether you have an equation, a simple algebraic equation whose coefficients are real, or the equation whose coefficients are imaginary or complex. Okay, in both the cases, the first thing which you should try whenever you get a polynomial form of equation is the factorization. Okay, so the very basic statement which I am giving you here is if you have any polynomial equation, whether it's a real polynomial or it's not a real polynomial equation, the first thing you should try is factorization. Okay, so here I will say let z raised to power 5 be t. So we have t square plus minus 2 plus iota times t minus 2 iota equal to 0. See, how did I get the idea of using the factorization? Normally I always try it. Okay, when I can't factorize, then I think anything else. Okay, now see, it's a simple middle term split method. The product of a into c is a quadratic. A into c is minus 2 iota, and it's the sum minus 2 plus iota gives us the middle term. So I will write it as a square minus 2t plus iota t minus 2 iota equal to 0. So if I take t common, t minus 2 plus iota common, t minus 2 equal to 0. So that means we have two possible roots, t is equal to 2 or t is equal to minus iota. So that was the algebraic part, a simple algebraic part of the question. Now again the question zeroes down to the concept of roots of unity, because the first one is z raised to power 5 is equal to 2. Okay, now I will write it as z upon 2 raised to the power 1 by 5 whole raised to power 5 is equal to 1. Now I will be replacing this term as capital Z, so capital Z raised to the power 5 is equal to 1. Okay, now look at the question statement. We have to find all such number of such z whose real part is 0 and which satisfy this equation. So which z do we need? Which are the roots of this equation and for which the real part of z is 0. Okay, now let's come back to this form. See, fifth root of unity. So fifth root of unity, so we have 5 roots, so one root is of course 1. Then 360 degrees. See, we have to place 5 roots at equal angular distribution on the argand plane. So 360 divided by 5 is 72. So one root will be at an angle, let's say alpha, 72 degree, and the one alpha is squared, then its conjugate, and then its conjugate. So we have one root in each quadrant, bachon. Okay, so out of these 4 roots, how many roots are with real part of that root as positive, or how many roots we have whose real part is positive? So of course those are the roots which lie on the right side of the imaginary axis. So this is one, this is one. Okay, now see, so for z raised to the power 5 is equal to 1, okay, real part of z positive imply we have two such roots. Yeah, as you can see from this figure, but we are talking about small z. But see, will that make any difference? Because small z upon 2 raised to the power 5 is capital Z. Okay, so that means small z is 2 raised to the power 1 by 5 times capital Z. Isn't that, bacho? So if the real part of capital Z is positive, then the real part of small z is also positive. So that means this equation, among the roots of this equation, we have just 2 roots whose real part is positive, or real part is positive. Okay, so now let's come back to the another one. So another one is z raised to the power 5 is equal to minus iota. Now what? So I will again convert it to the root of unity form. So I will write it as z upon minus iota whole raised to the power 5 is equal to 1. Now considering again this as capital Z, so capital Z raised to the power 5 is equal to 1. But remember here small z is minus times capital Z, bachcho. And we need the real part of minus iota capital Z to be positive. Be very clear about it, because the real part of small z has to be positive. Okay, now if I write my capital Z as a plus iota b, so minus iota z will be minus iota a minus b, rather plus b, bachcho. So the real part, see, the real part of minus iota z is actually the imaginary part of capital Z. Fine. And what we need is, we need real part of minus iota times capital Z to be greater than 0. So that simply means we need imaginary part of capital Z to be greater than 0. Now let's come back to this equation. Z raised power 5 is equal to 1. It's the same case. It's the same case. Now what are we looking for? So here we are looking for those capital Z, those roots of this equation whose imaginary part is positive. So how many such roots are there? So imaginary part is positive means those roots which are about the real axis. So one this one and another this one. So again, how many roots we have here? So again, we have 2 such roots. So how many total such Z? 2 in this case, 2 in this case. So the answer should be number of Z are 4. So I believe all of you would have understood the solution, and that's again an important aspect. See, we had been continuously using the concept of roots of unity in one or the other form, the algebraic form and so many more. We will solve one more where there will be involved, like trigonometry will be involved in that question. Okay, so algebraic form, geometrical form, so many forms in which we can use this concept of roots of unity.